Today we're going to talk about variation. Variation is an application of functions, and there's 5 different types of variation that we'll discuss. The first is direct variation. If you have y equals kx, where k is a constant, any number, then we say y varies directly as x. Or we could say y is directly proportional to x. So for example 1, it says the number of gallons of water, W, used when taking a shower varies directly as the time T in minutes in the shower. A shower lasting 5 minutes uses 30 gallons of water. How much water is used in a shower lasting 11 minutes? So when we get to several different types of variation, you're going to wonder, how do I solve this? How do I know which one to use? And it tells you, like right here, varies directly. Okay, so that's how we know to use direct variation. So we're going to use y equals kx. Okay, instead of y equals kx, it says W varies directly as t. So we're going to change that to W equals kt. So the first step when solving variation problems is to find k. So we were told that a shower lasting 5 minutes uses 30 gallons of water. This helps us find k. Now that we have k, we can write an equation, W equals 6t, plugging in for k, and that makes us have a function, an equation that will work for any values of w and t. So when it asks how much water is used in a shower lasting 11 minutes, then we can plug in 11 for t and find out that it's 66 gallons. And there's an equation of it, graph. Direct variation with powers. It says y varies directly as the nth power of x. So n just being a power, a number. If it says y varies directly as the nth power of x, then you use y equals k times x to the n. So it's just like direct variation, y equals kx, except you've got an n on the x. It says the weight of a great white shark varies directly as the cube of its length. So you can see there the power is the cube. So the weight varies directly as the cube of its length. So there's our equation. A great white shark caught off Catalina Island, California, was 15 feet long and weighed 2,025 pounds. So remember, the first step is to find k. So we'll plug in 2,025 pounds, and the length was 15 feet. Cube 15, we get 3,375, and divide so that k is 0.6. That means our equation is W equals 0.6 L to the third. Then the problem asks, what was the weight of a 25-foot long shark in the novel Jaws? So we plug in 25 feet for the length. Cube 25 and multiply by 0.6 and we get 9,375 pounds. That's a lot. And another graph of that. You can actually see that the weight of sharks grows exponentially. Lovely. Inverse variation. If a situation is described by an equation in the form y equals k over x, then we say y varies inversely as x. So if you see in your problem y varies inversely, then you know to use y equals k over x. So example 3 says the length of a violin string varies inversely, there it is, as the frequency of its vibration. So let's see how we can write that. The length varies inversely by the frequency of its vibration. We've just plugged in for y and x. A violin string 8 inches long vibrates at a frequency of 640 cycles per second. So again, our first step is to find K. So it says a violin string 8 inches long vibrates at a frequency of 640 cycles per second. So multiply by 640 and we get 5,120. That's our K. Now we can plug in K to find an equation that will work at any time. And the last part says, what is the frequency of a 10-inch long string? So this time we have the length, and we're trying to find the frequency. Multiply both sides by F, divide by 10, and we get 512 cycles per second. Don't forget your units. And there's a picture of that. Combined variation. So where we put more than one thing together. If you see varies directly as n and varies inversely as x, then you're combining two things. You're varying directly as n, so you can see the kn there, and then inversely it's put it on the bottom as x. So we're using y equals kn over x. At least I'm assuming that on this problem. Let's read it and see. The number of minutes needed to solve an exercise set of variation problems. Varies directly as the number of problems and inversely as the number of people working to solve the problems. Okay, so there's our situation. So it says, again, the number of minutes, so I'm going to call that M, to solve an exercise set of variation problems varies directly as the number of problems. I'm calling that R because there's a lot of N's in here, so I'm using R for number. And inversely as the number of people, there's P, to solve the problems. Okay, so again, our first step is to find K. It says it takes 4 people 32 minutes to solve 16 problems. Okay? And so we'll solve that. 16K, 4 times 32 is 128. Divide by 16, and K is 8. So our equation is M equals 8R over P. There's 3 variables here, so we need at least 2 to solve. It says how many minutes, so we're looking for M, will it take 8 people to solve 24 problems? Well, the 8's go away, so it's just 24 minutes. And there's my attempt to graph that. Kind of funny. Yeah. Joint variation. Joint variation is like direct variation with more variables. So if you hear y varies jointly as x and z, then that means you're using y equals kxz. It says the volume of a cone varies jointly as its height and the square of its radius. So we've actually got joint variation with a power in here. As usual, our first step is to find K. It says a cone with a radius measuring 6 feet and a height measuring 10 feet has a volume of 120 cubic feet. So, start by finding K. So 10 times 6, that's 60K. Oh, I forgot to cube, or to square. Okay. So 6 squared is 36. 36 times 10 is 360. And then divide by 360, so K is 1/3. So our equation is V equals 1/3 HR squared. It says find the volume of a cone having a radius of 12 feet and a height of 2 feet. Square the 12, multiply by 2, and divide by 3, and you get 96 cubic feet. Or you could write that as feet cubed, either way. And that's it for variation.